Is IPv6 the future of the internet, or is it a failed technology? So, what do you think, Kevin?
I mean, we're going to run out of IPv4 addresses. I know they've been saying it for years, but we're going to run out at some point. Yeah, I think it's been slow adoption, which has been the case of lots of technologies, but I think we're going to get there. That IPv6 is going to eventually be the future.
I gotta be honest, I don't know. I'm thinking it's not going to happen.
And IPv4, IP version 4, has been the format that's been used for a long time. It's made up of 32 bits, which means each bit has two values. You can have up to about 4 billion IP addresses.
And some of them are reserved. Some of them always refer to your computer. Some of them refer to all the computers on the local area network with you. So it's less than 4 billion. I think it's closer to 2 billion, right?
Yeah.
Brian asked, why did they make it only 32-bit? And I read a funny story about that just the other day. Vinton Cerf said he was one of the inventors. He was the lead developer on the team that invented it. He said he went to the chalkboard and he wrote, we'll make addresses 32 bits. And no one in the room said anything. He said that if one person in the room had said, are you sure that's big enough? He would have made it 64 bits. But no one said anything, and that was it. He said very little thought went into it. They were just making stuff up from scratch. A couple billion computers seemed like a lot to him, and nobody suggested it might not be enough. Nothing more than that.
So anyways, there started being problems where that number of IP addresses is getting exhausted and running out, and other limitations with IPv4, so they wanted to make a new version, and so they made enhancements. They made the address space a lot larger. Now instead of 32 bits on the addresses, they're 128 bits, which exponentially increases the number of addresses you can have. Huge increase. With the huge number of addresses now, a lot of times the way that you could do local networks on IPv4 is you would have what's called a NAT, which would translate. You could have one address and translate that into a bunch of private addresses behind it. And then your local network a lot of times is like this, where the router has one address and then all the devices behind your router each have an IP address. But then when they go through the router, they get translated in the router.
So when you're at home, every device in your home network is sharing your router's IP address. So you only count as one.
Not your ISP gives you an address to your router or to your modem, and then they use that to talk on the internet. But now with IPv6, because there's so many addresses, each of those addresses on your local network can get their own IPv6 address that can be addressable on the internet, and you don't necessarily need the NAT anymore. It is still possible to do NATs with IPv6, but in a lot of cases they're not necessary, and people don't use them as much.
They have made so many clever improvements to get more gas out of IPv4, right? Back in the 90s, a domain name mapped to an IP address, and then that ran your web server. And you could do reverse DNS lookups. If you had an IP address, you could say, what is the name of this? And it would give you back www.amazon.com or whatever. So each IP address was like one server. That is not true at all anymore. You can have literally millions of names mapping to one IP address, and CloudFlare does. When CloudFlare puts their stuff in front of you, each of their web servers has literally 1 million websites it's fronting for. And then they made that even worse, in that they can have multiple servers now sharing the same IP address, each answering for millions of names. I mean, so CloudFlare, of course, are very server-side. They've escaped. They don't care about IP addresses anymore. They can jam as many things as they want. They can jam multiple servers, multiple websites onto one IP address. They've got this Anycast thing, their DNS server, 1.1.1.1. That's an IP address. It should map to a server. It doesn't. It maps to whatever CloudFlare computer is closest to you. It's an IP address. It's the IP address of CloudFlare's closest computer, thanks to the magic of Anycast. I think they've escaped. I think the big boys have all escaped. I think they don't care.
I think from the carrier side that they do care about IPv6. I mean, you see a lot of the cellular carriers have picked up. I mean, you see some that are T-Mobile's a lot of times IPv6 only, or there's a lot that are dual stack, that IPv4 and IPv6 at the same time. The carrier nets and everything, that they want IPv6 that each device can get its own address that's addressable with IPv6 instead of having to go through these huge nets.
But a bunch of the big services, GitHub is not available on IPv6. Having not gotten that just makes me think IPv6 just missed its window. That needed to be done years ago. And we'll talk more about GitHub, my feelings about them. So Vadim was saying that was the 32-bit address size was a compromise between packet size, networking overhead, and address pool size to cover all needs, I guess. You would think there would be this mathematical, spreadsheet or computer model somewhere where they said, well, if we make it 64 bits, that's an extra 32 bits per packet. It'll slow down the internet by 0.25%. It's not worth it. But again, my understanding from what Vincent Cerf said, nobody ever did that analysis. He just went to a chalkboard and wrote 32 bits and nobody said anything. And that was the entire analysis. All ISPs are resisting for migration to IPv6, having no financial motivation to do this. Even more IPv4 selling is a kind of business. Yeah, I mean, there are people making money brokering IPv4 addresses. So you're right. If there was a ton of money in IPv6, they would have grabbed it already, right? You know who loses is peer-to-peer. I mean, all these tricks to squeeze more mileage out of IPv4 are all about having multiple servers share one address. Both from the names, all these different names that look like different servers all go to one IP address. Now they're getting multiple physical servers. The clients lose, right? If I want to write an app that just connects to Kevin's laptop wherever it is, I don't have an address. Because he's natted, I'm natted. There's no real address for us to connect to each other.
Yeah, I guess that's what led to the rise of a lot of these things like WebRTC does with relay servers, where they both have to reach out and go through some intermediate server instead of being able to talk to each other directly.
So what happened to IPv5?
I don't know. What happened to it?
Yeah, I have to know this story too. There was a little company that came out with a new networking protocol, a startup, and they labeled their new software as IPv5. And they took that version number in the header. And it went nowhere. I mean, as far as I know, I think that it sometime in the 90s got installed on 40 computers and then they went out of business and it got uninstalled. The IETF people were, nope, that number's been used. We never reuse a number. Now we have to move on to a higher number. It basically didn't exist. Some people just used it for this weird little protocol that never took off. Maybe IPv7 is the future. So one thing I think about a lot is what could the IPv6 people have done differently to succeed? Even with 2020 hindsight, if you're making the addresses bigger, then anyone who hasn't upgraded the software can't talk to the new devices. I mean, things were going to break unless every single computer on the internet got upgraded. And that's the thing about IPv4, IPv6, IPv7. It is the base level of the internet. Other protocols like QUIC and TCP and stuff, you can make updates to them. And in a lot of cases, just the two computers at the ends need to be able to speak it. But the computers in the middle don't need to because they don't understand the protocol. All they see it as is an IP packet. As long as everyone speaks IP, they can carry the packets all the way to where they go, and they don't have to worry about the other protocols inside. Those aren't important until you reach the ends. But IP, that's that bottom protocol that gets packets all the way across the internet. So every single computer the whole way through has to be upgraded to this new software, or the whole thing breaks.
Yeah, I mean, there are hacks to get around it. You can tunnel IPv6 inside of IPv4 and things like that, but it's not necessarily efficient. It's a hassle to do. But yeah, I guess they come up with ways to try to get around that not every machine needs to know. But yeah, it's a headache trying to get everything updated. And yeah, I don't know what changes they would want to make in IPv7 or 8 at this point to improve on IPv6.
One of the lead guys for IPv6, his advice to the next generation is don't try it. Don't work on IPv7. No one will be willing to even discuss it for 30 years. There's no point. Move on. Do something else. You can do a new version of TCP. You can do a new version of whatever. There are lots of protocols we need, but nobody is going to want to even talk about a new version of IP for 30 years. Honestly, I think the guy was an optimist. It's been 15 years. It doesn't feel like we're within 15 years of wanting to do this again. Vadim asks, could I buy public IPv4 address from Speedify to receive all benefits from networking features and hosting own website?
Kind of. I know there's some services that allow you to just buy the address. In our case, you can get a dedicated server, which comes with its own IPv4 address. And so then you can do port forwarding through that address to your client devices and things like that. And that server is just yours or whoever's on your team if you have a team of people. So in that way, you can get your own static address and that address won't change. And you can link that to different services and things like that. But yeah, we don't have an option to just get a specific address for you without getting a dedicated server.
Do you have plans to add more VPN servers in Southeast Asia? When I used P2P, it forced me to connect to Amsterdam, which is thousands of miles away from my location. Bonding won't help in this condition. That is not because there aren't enough servers in Southeast Asia. That is for legal reasons. There are countries that have legal regimes that don't care so much about you running peer-to-peer. That's one thing. But at this point, most hosting providers in the world have no tolerance for servers that are doing BitTorrent. And that is why you route it to Amsterdam, because they don't care. So we can let you run any protocol you want. But pretty much every other hosting provider, if they see you running peer-to-peer, they just They're not going to tolerate that nonsense. Whether or not it's nonsense, it's a different issue. That's how they see it. I'm presenting their point of view. Lads, just got Speedify for my 92-year-old grandma. It really just works. I'm her favorite grandkid now. Thanks, guys. Woo! That's what we're here for. Could Speedify act as a networking firewall service eventually? Any plan in that direction to add such a feature? One of the next things up is going to be, self-hosted servers. Right now, it's NATed, as we talked about. So every connection has to come from you first. So we don't have a whole sophisticated thing to let through certain connections unless you have a self-hosted server, and then you can have port forwarding. So I think more is coming. We did a hackathon here, actually, and a bunch of the interns were playing around with an AI model to detect traffic that looked like someone was attacking you.
But there are some basic firewall features in Speedify to prevent outgoing traffic from your computer if you want certain things to be blocked. If you're on a version that has the Speedify command line, so one of the desktop versions, Windows or Mac or Linux, there are firewall commands there. You can block certain ports or IP addresses or domains. Currently, we haven't kind of exposed that in the UI to everyone yet, but there are some basic firewall features in there that you can block certain traffic with Speedify if you want to.
And there is some built-in stuff. The IP addresses that are used to run massive botnets, you can't connect them through Speedify. The virus takes control of your computer and tries to go online. We don't let it call home. There's no reason you would be connecting to those IP addresses, so we cut them off. If in some weird world you could only have one firewall layer, so network-wide or per device firewall, which firewall would you choose?
I mean, my thought would be network because, you have to configure on each device separately, and not every device is going to have support for firewall stuff. It seems easier to just handle it.
So many devices are mobile. I go to a coffee shop, and I'm completely reliant on the coffee shop to protect me. So I guess I'm going to go with per device. There you go. Kevin and I disagreed. You got both answers.
And I guess, it's harder and harder to detect things in the middle now with, lots of the different things that end devices are doing and encrypting things end to end. It can be hard to tell with the the network level firewall. There's ways to get around that stuff.
Zelda asks, what's the importance of HTTPS and why is it used so often compared to HTTP?
That's a good question. So the S stands for secure. The main difference between HTTP and HTTPS is that HTTPS is encrypted. It's encrypting the requests and the data that's going to the server. With HTTP, it was possible that things in the middle could intercept your traffic and modify things. And
could and did.
Yeah, a lot of times you'd see things that would inject ads into HTTP requests and redirect it to other places. So there's a security concern there. So HTTPS makes sure that you're talking to the server you think you're talking to and encrypts all that so nothing in the middle can tamper with that. Depending what version of HTTPS you're using, things can still see what you're talking to. Obviously things in the middle can still see the IP address, but in terms of what specific domain and stuff you're talking to, it's based on kind of the underlying encryption and stuff. There are, ways that it can now even encrypt what domains you're talking to and things like that, to really kind of hide what you're talking to from things in the middle like your ISP.
And us, oddly, right? It stinks because, we're well behaved. There are things we could do if we could see your traffic, like notice if they blocked you because they think you're coming through a VPN and see if there's a different way to the server to get you through, but we can't because your traffic's all encrypted, so no bad people can spy in the middle, and that includes good people spying in the middle, is what it is. Gotta keep ratcheting up the security because people were abusing it. ISPs were abusing it. They were looking at your traffic and selling your profile, and they were inserting ads into websites. It was bad. All right, Tracker asks, how do NAT and security groups behave differently under IPv6 compared to IPv4?
This is specific to AWS that he's asking about.
Specifically AWS. We'd have to ask Brian what he knows about that.
Yeah, and as I was saying before, with IPv4 versus IPv6, in general, a lot of times NATs aren't used with IPv6, although you can use them. A lot of times, because there's so many addresses, they're not necessary, and each endpoint device is just getting its own address that it can communicate with. But I don't know specifically in AWS how they handle NATs.
Yeah, there was that huge fight for a long time where the IPv6 people were claiming that there was no reason to ever use a NAT under IPv6. And people came up with plenty of perfectly correct examples of where NATs would still make sense under IPv6, and they just insisted they were wrong. The IPv6 people lost the debate, but kept insisting they won it. And at the time, it certainly felt like that was one of the things slowing it down. I think a lot of people actually lost enthusiasm based on these people taking hard stances where they were technically wrong. All right, Brian has an answer here for Tracker. I think AWS NATs don't support IPv6 at all. You need to use egress only. internet gateways for IPv6. Security groups behave about the same, but defaults to security groups usually don't include anything for IPv6. Yeah, it's tough. So many services still not available on IPv6. GitHub. Speaking of GitHub, do you notice the latest? So that the CEO of GitHub resigned, and they announced, so GitHub is owned by Microsoft. Microsoft is not going to appoint a new CEO for GitHub. Instead, now GitHub is going to report into their AI product groups. GitHub has gone from being like the division of Microsoft that took care of the developers to now it's just a marketing arm for the AI product. This is a disaster, right? A slow-moving disaster. I feel like they had such a strong brand. I think they did sell a lot of AI products, right, by bringing developers AI products that would work for them. But I think these subtle differences in the boardroom make a huge difference. Now their job isn't to take care of the developers by bringing them AI products. Now their job is to take care of the AI products by shoving them onto the developers. I think you're just going to see the GitHub brand kind of go away, right? They're going to become, copilot.com or something. It's going to be as dumb as the X thing. How do I know the IP? I know they're not IPs on mobile data works. How does the data find the right way, even if the cell phone tower is different from where the request was? The cell phone tower makes a GRE tunnel, which basically is a VPN tunnel, back to the internet gateway of the ISP. And so you're using the gateway's IP basically, right? There's a NAT there. And they have a clever system when you change towers, it makes a new GRE tunnel from the new tower back to that same internet gateway and tells it, use this tunnel now to talk to this guy. And without reassigning IP addresses or doing DHCP or any of that nonsense, just your very next packet going out goes out over the new tunnel to that same IP address. And the next packet coming in that gateway goes down the new tunnel to where you are now. So it's basically a VPN that you're always VPNing to the same gateway to get you to the internet. Pretty clever, and it works really well. That's also why if you do traceroute and try to see all the hops, you don't see any hops to their network. You reach the tower, and then you come out the gateway. And you do not see any routers at all inside your mobile carrier because your packets got encapsulated into this tunnel and sent across. So they don't see any of the routers in the middle because it's not really your packets anymore. They're VPN packets. So hopefully that makes some sense. So when are we going to see another release of Speedify?
We're wrapping up some different features and stuff. And
Starlink improvements are nice.
So yeah, a few releases ago we'd added that we can pull different stats and alerts from the Starlink dishes, but now we've expanded that we're pulling a lot more information. From
it shows the alignment info, like which way your dish should be pointed, which way it is pointed. It tells you if Starlink has purposely slowed down your internet because you've used more data than you're supposed to. It tells you what else? There's some other really neat things. Oh, software versions, hardware versions. All that stuff now shows up in Speedify. And it's neat because if you have multiple Starlinks, it keeps them separate. You can click on each of your dishes. You can see the software versions on each one. You can see the speeds on each one. So it's really, really nice. So, of course, there's the Miri. We haven't talked about this for a few weeks. We just keep doing software updates on this bad boy. So Miri Technologies, they've got this hardened router for professionals. It's got 4 Ethernet on the back, any of which can be internet connections or downlinks. It has a 4G and a 5G SIM card, 2.4 and 5 gigahertz Wi-Fi, 2 front USB ports where you can tether all sorts of different devices, Android phones, iPhones, 4G, 5G card, and it's all powered by NPF batteries. And of course, it's all running Speedify. So for video professionals, this is like the rock solid device to take out in the field. Amazon announced own satellite network, but no news since last year so far. No, Vadim, there's plenty of news. They are launching satellites. They fell behind schedule, but now they have hired SpaceX, who launched their satellites for them, and SpaceX is launching their satellites. I think they're still below 100, and I think, they're not going to turn on the service. Are they shooting for 3,000 satellites?
I don't remember.
Something like that. So they're still pretty far, but no, they have teamed up with SpaceX. So SpaceX is helping build Amazon's competitor to SpaceX Starlink. I guess the money is right. I think the truth is SpaceX needs to launch rockets, right? I think they spent so much money designing those rockets and building those launch sites and training those people that they must keep launching. So they have now done 100 launches so far this year. Might even be 101 by now. They're doing 2 or 3 a week. So by the end of the year, they might hit 150. How many total space shuttle launches were there from 1981 to 2011?
I don't know off the top of my head, but
135. The entire 30 years of the space shuttle program represented 135 launches. And SpaceX is going to do more than that this year. The level of expertise that SpaceX is developing is incredible. You've got people there who have launched more rockets than anyone on Earth, right? You probably have B teams who have launched just 50 rockets, right? They've got teams, they've got backup teams, they've got expertise. They've got, all of their different rockets use the same engine. I mean, that engine is so well tested. The big rockets will use 13 of them. The little rockets will only use 9 of them. If you look at the bottom, it's not one huge rocket thruster on the bottom of Starlink. It's a bunch of little ones. And it's this one engine they've designed that they just keep using and, improving, little improvements. That's one of the most reliable technologies out there. So, yeah, there are a bunch of videos on the Speedify channel about Kuiper. All right, there we go. The up-to-date stats. They hit 102 satellites. And they're aiming for 3,236. But I gotta say, Starlink crossed 8,000. For ages, we've been saying that Starlink has 6,000 satellites, but it's actually been growing. They crossed 8,000 now. All right, Roy says, I'm considering getting Raspberry Pi 5. Is 8 gigabytes sufficient RAM for Speedify? I set up Ubuntu and Speedify and nothing else running, and it used 300 megabytes of RAM. If you're really just running Speedify on a Raspberry Pi, any amount of memory they sell is more than you need. Now, if you're going to start running all these other apps on there, if you're going to run Home Assistant and crazy firewall stuff, it can get really high really fast. But if it's really just a Raspberry Pi just doing Speedify stuff, I think 2 gigabytes is now the smallest they sell, and that's totally fine. So yes, 8 gigabytes is sufficient. If there are options to go lower and all you're doing is Speedify, you can go lower. One last question. Did you use a direct mobile Starlink? What was your experience using this? Meaning a T-Mobile Direct. I have not. Is it just texting? The commercials are bragging about how you can text from anywhere in the world.
At the moment, but I thought they had plans that you could start doing other stuff over it in the near future. I don't know the exact timeline, but I thought they were announcing that you could use other apps and stuff over it coming soon-ish.
Yeah.
But yeah.
There were bandwidth issues. It's they're beaming down 7 megabits of bandwidth per 100 square miles or something. You suddenly realize that you sure can't have everyone in Philly on that. We would run out of bandwidth pretty fast. Nice things about texting. Low bandwidth. You don't notice latency.
Right. Yeah.
If your text takes a whole extra second to get through, which I don't think it will, the Starlink's pretty low latency, but nobody would notice, right? Or voice calls, people freak out when you had extra 100 milliseconds. So I don't actually have real experience with Starlink. I know it's available now on T-Mobile. If you're on a rooftop or in the middle of nowhere, your phone will be able to, use Starlink to let you connect. I bet it works just fine. It won't make it into buildings, and if you're in a crowded area, it's going to run out of bandwidth. And so they've set it up that if it's T-Mobile, but if there's a working tower, you'll use the tower first. So you're really going to have to drive into the middle of nowhere to get a chance to use it. But for me, it's going to be a haul because T-Mobile has pretty good coverage over here. All right, I hope you guys found this helpful. I got to get Kevin back to work. The release of Speedify don't just happen from me talking about him. Thank you, Kevin. Thank you, everybody. And I'll see you guys online. We make our engineers live stream every Wednesday. So subscribe to be able to put them on the spot and ask them all your Speedify and technical questions.